Hi, so after last week I did a little bit of thinking and I decided that I'm going to need a free list. So I've set about working on a free list, and the main two parts of this particular object is this one here, allocate block, and this one here, free block. And it's sort of pretty unintrusive. The blocks on the free list have a next pointer, and the first, like the constructor, when you run that, if the file is empty, then it will create a free list at block 0, with a pointer to the start and a pointer to the next one. I'll take you through the allocator. So this one here, allocate block, is where the magic really happens. So first of all, it expects that there is a first block, and if it can't find one, it complains. And then it reads a file size from the first two pointers in the file. That's the first block offset and the last block offset. So just like a double-ended, just like a queue, you want to have a start pointer and an end pointer, where you append objects at the end of the queue, and you then pull objects off the start of the queue, and that's how this free list works. Now, if it doesn't find, I guess I'll do the second part first. If it can't find a first block, then it will just allocate a new one, and that one essentially is just finding. Let me just find that file. Allocating a new block is just finding the size of the file and writing a block at the end, and that gets a new record or a new block that you can start adding stuff to. And otherwise, if it can find a free list block, then it sets about unwinding the parts of the list that it needs to. So it finds the first block, which is the block that it's going to return. It's this one here. It gets the new free list first block. So this is like the first entry in the block that we're going to pull out. And then it writes that new free list block offset to the start, or to the that first 0th block that's in the file. And if the new free list first block offset is 0, in other words, it's at the end of the file, then actually we also clear the end pointer from the list, and then we write all the data out, and that finishes the transaction. So that's done, and then freeing is almost the reverse of that. We take our block and we essentially find the end of the list. So reading the first block, this one is just clearing the block that we're about to get rid of, so we don't want to leave any extra data lying around. We read the first block, and then from the first block we get the start and end block offsets, and then depending on whether or not those are 0, we will, if the last block is 0, then we will either wire in that new block to both the start and the end point, or just at the end, and then we'll write that those blocks to the file and finish up. So how that looks in practice is, and I've got a test here that I've run to make sure that it works, but you can allocate a new block, and then you allocate another one, and as many as you like, and then you can free those blocks using free block, and then you can allocate those blocks again, and I've got a test check here which says that the first and the fifth block and second and sixth and third and seventh are blocks that it had previously allocated and freed. So that's working. Pretty happy with it. Love to know your feedback. Hit me up on email, Twitter, or on Threads. See you next time.